Okay, Algebra 2 fans, our topic for today, 1-7, solving absolute value inequalities. And before we start, let me give you your joke of the day. I tried to take a picture of some fog. I missed. M-I-S-T, missed. All right, so before we get into the absolute value inequalities, let's do a review of compound inequalities, which are using the words and or. So number one, we're going to solve 4x minus 3 greater than negative 15 and 3x plus 2 is less than 14. So what we'll do is we're going to solve both of these. So treat these like an equation. So we're going to add 3 to both sides. We get 4x is greater than negative 12. Divide by 4. We get x is greater than negative 3. So that's the solution to that inequality. Over here, we're going to subtract 2 from both sides. 3x is less than 12. Divide by 3, and we get x is less than 4. So we've got x is greater than negative 3 and x is less than positive 4. Now you can write it like this, and that's fine. We can also put this as one inequality, where we would say negative 3 is less than x is less than 4. Instead of x is greater than negative 3, we've got negative 3 is less than x. Okay? Now, by doing it this way, if we want to graph the answer on a number line, so there's negative 3, there's positive 4, since both of these are less than, there's no equal to part, this is going to be an open circle at negative 3, an open circle at 4. Now the solutions are where x is between negative 3 and positive 4. So that could be the number 0. Think of numbers between negative 3 and 4. That could be 1. It could be negative 1. It could be negative 1.9. So to show that, we're going to shade everything in between. And I like to shade it. I'll just draw a line connecting my two circles. So every number between negative 3 and positive 4 is a solution. Now in number 2, now we have the word or. So again, I'm going to solve this. So I'm going to add 2 to both sides and then divide by 4. So we get y is greater than or equal to positive 4. Or over here we're going to say plus 4. So 3y less than or equal to negative 9. Now divide by 3, you don't change the symbol because we're dividing by a positive number. The only time I would switch this is if I was dividing or multiplying by a negative. So in this case, y is less than or equal to negative 3. So there's our solution. Now on a number line, you'll notice that we actually have the same two values. We have negative 3, we have positive 4. The negative 3, less than or equal to, so because of the equal to part, I'm going to have a closed circle. What that means is that negative 3 is part of the solution. That is an answer. If I plug negative 3 in, it makes this true. It makes one of them true. So less than or equal to negative 3 is going to go to the left. Those are the numbers that are less than or equal to negative 3. Or y is greater than or equal to 4. Now again, the equal to part, that means that 4 is part of the solution. So I'm going to shade that in. It's closed circle is how I say it. All the numbers greater than or equal to 4 go this way. So typically what happens when you have an or problem, the graphing will go in opposite directions. Typically when you have an and problem, you're going to be shading between. All right, so now let's talk about absolute value. So as a review, let's graph the solution set for absolute value of x equals 2. There are two values that make this equation true. Positive 2 and also negative 2. So x could be positive 2 and x could be negative 2. Absolute value is the distance from 0 on the number line. So from both positions, this is 2 spaces away and this is 2 spaces away. So remember that the absolute value of a negative number is still positive, and the absolute value of a positive number is also positive. So the question is, what happens once we make this an inequality? Absolute value of x is less than 2. Can you think of numbers that you can plug into this that will give you an absolute value less than 2. Maybe number 1, or maybe 1, for example. 0, negative 1. The absolute value of negative 1 is also less than 2. So it looks like, now if I try to do 2, absolute value of 2 is less than 2. That's actually a false statement. I'm going to put an F there. That doesn't work. The absolute value of negative 2, that's equal to 2, so it's not less than 2. That's a false statement. So what I'm going to do is put an open circle at 2 and negative 2. Think of it as an equation to start from. So there's negative 2 and 2. The only question is, when are the values less than 2? Now we said 1 works, 0 works, negative 1 works, 0.5. 1.9 absolute value is less than 2. So is negative 1.9 absolute value. So everything between these is going to be true. So notice that absolute value of x less than 2. When is my distance from 0 less than 2? It's between these two numbers right here. So this looks like an AND problem. This looks like our first example in the compound inequality. Okay, now if we slide this up, graph the solution set for absolute value of x is greater than 2. Now again, if I think of this as an equal sign, my answers would be negative 2 and positive 2. But the question is, where are numbers where the absolute value is greater than 2, where I am more than 2 spaces away from the number line? Well, in terms of positive numbers, if I put a 1 in, absolute value of 1 is 1. That's not greater than 2. 3 would work. 4 would work. As a matter of fact, anything to the right of 2 is going to make this true. So I'm going to graph that to the right, that piece. Now it looks like anything between negative 2 and positive 2 is not going to work. It's not going to be greater than 2. So what about negative 3? What if I test, I'll say negative 3. Is that bigger than 2? And yes, because that's 3, which is greater than 2. That's a true statement right there. So negative 3 is part of my answer, but so is negative 4, and negative 4.5, and negative 5.9999. So everything to the left of negative 2 is also going to work. So these are my solutions. These are the values that make this true. Notice that this is an OR problem, very similar to an OR problem. And notice that the inequality symbol was greater than. When's your distance from 0 greater than 2? If I'm to the right of this and to the left of this. When is my distance from 0 less than 2? When I'm between these two values. Okay, so how about number 6? How about absolute value x plus 1 less than, or greater than or equal to 5? Now, in your mind, think of this as an equation, okay? What values would make this equal to 5? If I put a 4, if I say 4 plus 1, absolute value, that's going to be equal to 5. So I'm going to put a circle at 4, and I'm going to close it because it's greater than or equal to. Now, let's see, what else can I put in there? I could put a negative number. I could put a negative 6 in. Negative 6 plus 1 is negative 5. Absolute value of negative 5 is positive 5. So negative 6 is my other value here. I'm going to close it. Now the question is, which way am I going to shade? I am looking for where the distance is going to be greater than or equal to this. So when is the distance going to be more than that 5? What if I try 0? Okay, what if I pick a number between these two? If I take 0 plus 1, is that greater than or equal to 5? And the answer is no, that's a false statement. So I'm not going to shade anything between. What if I take a number on the outside? What if I take 6? Is 6 plus 1 greater than or equal to 5? This would be 7. Absolute value of 7 is 7. That's a true statement. So it looks like all the numbers to the right are going to be true. What if I try something to the left? What if I try negative 7? So absolute value negative 7 plus 1, is that greater than or equal to 5? Well, that's negative 6, absolute value, which is positive 6. Is that greater than or equal to 5? That's true. So I'm going this way. So here's the idea. If the absolute value is greater than or equal to a number, that's an OR problem. If the absolute value is less than a number, that's going to be an AND problem because you're going to be looking between those two values. Okay, so let's go ahead and flip it over here. The way that I remember this, I say remember the goal. And what I do is I put a slash between the O and the A. So notice you got GO. G is for greater than. Anytime you have greater than, and that includes greater than or equal to, that's going to be an OR problem. You're going to be shading on opposite sides. Okay? It's going to be looking like that. Anytime you have an AND problem, so AL, GO, greater than is an OR, and is going to be a less than. And is less than. So if you have less than or equal to, that's an AND problem. And if these are the solutions, you're going to be shading between. Okay? So if your absolute value is less than, you're going to be shading between the two values. If your absolute value is greater than or equal to, you're going to be shading opposite directions. Greater than is OR, less than is AND. Okay, so let's take a look at number 7. Absolute value of 2x minus 1 is less than 9. So the distance has to be less than 9. So we're going to be looking for values between. Okay, this is going to be an AND problem. Now, absolute value, when you solve an equation, you have a positive case and a negative case. The same thing is going to be true here. We're going to say 2x minus 1 is less than 9, and that's the positive case. The negative case, 2x minus 1. Now there's going to be a negative 9. That's the negative case. Okay, I don't change what's in the absolute value. Now here's the thing though. This is kind of like I've multiplied by a negative 1. When you have an inequality and you multiply by a negative, you have to change the symbol. So less than becomes greater than. And what this does, this gives me two separate inequalities that I have to solve. Now I can do it like this. I can do this, positive case, negative case. Excuse me. But what might be easier, I'm going to set this up as a compound inequality. Negative 9 is less than the 2x minus 1 is less than positive 9. The 2x minus 1 has to be between negative 9 and positive 9. So I'm going to do it this way. So to solve this, I want to get the x by itself. So I'm going to move the negative 1 first. So let's go plus 1. And we get negative 8 less than 2x less than 10. And then I'm going to divide by 2. That's 2 times x, so I'm going to divide by 2. And we get negative 4 less than x less than 5. There's the solution. So on a number line, the negative 4 and the 5, those are both open. Where's the variable? It's between the values, so I'm going to shade between. And that's our solution set. So I'm going to stop right there. We're going to stop part 1, and we're going to pick up with part 2.